Alright, if you're watching this video, it's because you were absent when we did this lesson, so let's get started with the 3 practice problems from the PowerPoint. The speed of light in a vacuum is 3e8 meters per second. What is the speed of light through a material with an index of refraction of 1.70? To solve this problem, you need this equation. N is equal to C over V. N is the index of refraction here. It's a unitless number. The speed of light in a vacuum, that's 3e8 meters per second. That's C. And we're looking for the speed of light through a material. This is our unknown V. So we'll rewrite this equation, N equals C over V. The target is V, so you need to multiply it by both sides, on both sides of the equal sign. Then this becomes V times N equals C. Divide by N on both sides. And you've isolated your unknown, V equals C over N. We'll plug in now 3e8. That's meters per second, units on top, a unitless 1.70 on bottom. Plugging this into the calculator, 3 second, comma, 8 divided by 1.7, and we get 1.76 E8, and 76 E8, or times 10 to the 8 meters per second. So the speed of light slows down through this medium. Practice 2, a beam of light travels from air into an unknown medium. The angle of incidence is 37 degrees. The angle of refraction is 23 degrees. What is the material's index of refraction? There should be an apostrophe here. My apologies. Whoops. Okay, we're going to use this equation. N1 times sine theta 1 equals N2 times sine theta 2. The beam travels from air. Inside air, N1, that's going to be equal to 1.00 because it's the initial medium. Into an unknown medium, N2, we're going to be looking for this material's index of refraction. The incident angle, this is theta 1. The refracted angle, that's theta 2. We're looking for N2, so rewriting the Snell's law equation, N1, sine theta 1 equals N2. Sine theta 2, divide both sides by sine theta 2. This isolates N2. So into the calculator, we will plug N1 times sine theta 1 over sine theta 2. This will equal N2. N1 is just 1.00 times sine of 37 degrees divided by sine of 23 degrees. Grab your calculator. First thing, you make sure your calculator is in degree mode. Scroll down. If you're getting strange numbers, negative numbers, your calculator was in radians, so be careful, especially when we take the test. Now we'll plug in 1 times sine 37. You could, of course, omit the 1. Any number times 1 is just that number itself, divided by sine 23. Enter, and this is 1.54. Again, the index of refraction, it is a unitless number. Let's practice 2. Practice 3, last one. A beam of light travels from water, that's N equals 1.33 into air, N equals 1.00. The angle of incidence is 15 degrees. What is the angle of refraction? So in this case, we'll use the equation again. N1 sine theta 1 equals N2 times sine theta 2. Now we're solving for theta. So the beam of light starts off in water, so this is going to be our N1, into air, N2, angle of incidence, theta 1, angle of refraction, that's theta 2. N1 sine theta 1 equals N2 sine theta 2. Now we're going to divide both sides by N2. So now N1 over times sine theta 1 over N2 gives us sine theta 2. To get the theta out from under the trig function, you have to do sine inverse on both sides. So we are going to take sine to the negative 1 on this side and sine to the negative 1 on this side. Sine of negative 1 Taking sine inverse of sine just gives us theta sub 2. The signs cancel out. So rewriting theta 2 will equal inverse sine of N1, which is 1.33, times sine of 15 degrees divided by our N2, which is just 1.00. You could leave that off or you could plug that into the calculator. Grabbing the calculator to get inverse sine, you do second sine. There's your sine inverse, 1.33 times sine of 15 degrees divided by 1, but I'll just leave that off. This is 2.01 E1. So two ways you could write this, but I want you to include the units. Theta 2 equals 2.01 E1 degrees, or 20.1 degrees. Okay. I hope you found this video helpful. Thanks for watching and study well.